Alright, today we'll learn how to find the slope of a tangent line, and first we'll review slope, and slope is just rise over run. So the slope of this line, rise is -2, run is 1, we get the slope of -2. And when we find the slope of a tangent line, that is calculus, so we'll be doing calculus today. If we wanted to find the slope of this curved line, we just have to choose a point and then find the slope of the tangent line at that point. So let's think about what a tangent line is, or learn what a tangent line is. Here's a tangent line, and this is not a tangent line. So based on this example and this non-example, you come up with a description of what a tangent line is. And then we want to take your description and test it for this. This is a tangent line at this point, and it's not a tangent line here. And here we have a tangent line, and that's not a tangent line. So hopefully you see that when we talk about, we can't just say that a tangent line only touches the curve once, like maybe here we say the tangent line touches once, but here it touches twice, so it's not a tangent line. Well, then we have to deal with this, which it does touch twice, but it's still a tangent line at that point. Here it's not a tangent line at either point. And instead of saying the tangent line cannot touch more than once, we can say within a small enough interval, the tangent line will only touch once. So when we and another way we want to look at it is if we zoomed in on this point, if you have a curved line and you look closely enough at it, it'll look straight. And if we just extend that straight line, if we look really closely right here, that looks like a straight line, and just extend it, and that's what a tangent line will be. One way to understand a tangent line. Also, we want to review what a tangent line, or learn what a tangent line can tell us about position and velocity. So the blue line could be a position function, and y values are in feet and x values are in minutes, so we have time and distance. If we have the slope of the red line, and the red line is a tangent line, the slope of that tangent line is also called the instantaneous velocity at t equals 1. So that's the velocity at an instant. And the green line is called a secant line, and the slope of the secant line is called the average velocity over an interval. So it's not at one time, it's over an interval of time. So that's some vocabulary. And now let's look at how we can find the slope of a tangent line. Alright, if we want to find the slope of the tangent line, we only have 1 point, but our slope formula requires 2 points. So this is what we can do. Let's choose another point out here, and we'll make a secant line. So this is x plus h. And we could say that the slope of the red line is kind of close to the slope of the blue line, but we can get closer. At least it's the same sign. It's not very close, but it is the same sign. So now let's do this. We chose this point by adding a number to x. So this x value is now x plus h. Why don't we just take that h and make it smaller? We can move in here. And now this will be x plus h2. So call this x plus h1. And if we draw a secant line there, the slope of this line is closer to the slope of the line that we want than the red line. And what we're doing is we're letting h decrease. As h decreases, we're going to get closer and closer to the x that we want the slope at, and we're going to do that with a limit. Every time we draw a secant line, we have 2 points, and the slope of the secant line is y2 minus y1, x2 minus x1. This is also called the difference quotient. Quotient means division, difference means subtraction. That's where the name comes from. So we could rewrite, instead of writing a y, we could call that f of x2. Instead of writing a y here, we write f of x1. And in the graph that we looked at, our x2 is going to be x plus h. So here's x2 and there's x1. We're going to go we're going to do f of x plus h minus f of x. And then x plus h minus x. Well, x minus x is 0. We'll be left with an h in the denominator, and we can just write it as f of x plus h minus f of x over h. That is the slope of the green line, the slope of the red line. It's the slope of any of these as long as we're choosing the correct value of x plus h, or the correct value of h. It represents any slope that we want it to be, depending on the h. But we can do the slope of the tangent line and we get that by letting h go to 0. We saw that in the graph. If h is large, then we're out here and the red line has a slope that's not close to the blue line. As h decreases, here we have a smaller h. It creates a secant line that has a slope that's closer to the slope of the tangent line. Then we just get smaller and smaller. H decreases. H is going to 0, which means we are approaching x. The points are approaching x, and we can say that the slope of the tangent line is the limit as h goes to 0 of f of x plus h minus f of x over h. And that is the slope of the tangent line. It's also called the derivative of f, and that's calculus. Find the slope of the tangent line to y equals x squared at the point 1, 1. So let's look at what's happening graphically. So we have this graph, we want the slope of that line at x equals 1. And the slope of the tangent line, here's some notation. We could write y prime, or since we have a y there, we would use y prime, f prime. Each of these means the slope of the tangent line is also called the derivative. So we can write y prime at 1, the derivative of y at 1, or the slope of the tangent line of y at 1, that they all mean the same thing, is going to be the limit as h goes to 0, f of 1 plus h minus f of 1 over h. F of 1 plus h. So f is x squared. And that's a helpful way to write it out. You copy the function, but leave a space wherever there's an x. Sometimes there's more than one x, and we have to leave more than one space. But here we see an f, so I leave a space. Here we see an f, and we leave a space for that. And we're going to put 1 plus h, and then 1. And that's 1 plus 2h plus h squared minus 1. So 1 minus 1 is 0, and let's factor an h out of that. Cancel that. As h goes to 0, we get a 2. Also remember that we would normally, or we always, substitute first. If you put a 0 there and a 0 there, you get 1 minus 1 over 0, which is indeterminate, and then we have to continue with factoring and rewriting. So we see that the slope of the function at 1 is 2. Alright, pause the video and try that one. So we have a parabola, and we want the tangent line at 3. Slope of the tangent line at 3. So we'll have y prime at 3 equals f of 3 plus h minus f of 3 over h. Oops, limit. The limit as h goes to 0. Limit as h goes to 0. And we have x squared, so it's going to be, everywhere we see an f, we'll put a space squared. And in that space, we'll have 3 plus h from there, and 3 from there. This gives us 9 plus 6h plus h squared minus 9 over h. Nine minus 9 is 0. We can factor out an h. And so the limit is 6, and that means the slope of the tangent line at 3 is 6. Alright, just a little change here, and that is we're not going to specify where to find the slope. We want to find the slope at any point. And we could get a quick sketch. We know the y-intercept is 2, and if we can't factor, but it's going to go like this. We want to choose some x value. X is going to be anywhere, and then we have an x plus h, just like we saw in the beginning, and we're going to let h go to 0, and that will give us the slope of a tangent line anywhere on the graph, because x could be at any point. So we have y prime of x. Now we don't put a number there. We're going to say we want the slope at any value. So we'll do limit as h goes to 0, f of x plus h minus f of x over h. Limit as h goes to 0. Alright. F. Here's an f. We copy the whole thing, put a space for each x. So we have f, that whole thing is f, f, that whole thing is f. It's going to be something squared minus 4 times something plus 2. Something squared minus 4 times something plus 2. Something squared minus 4 times something plus 2. Over h, and this is going to be x plus h. X plus h. Over here it's just x. And if we expand everything, we have x squared plus 2xh plus h squared minus 4x minus 4h plus 2. That is all from there. Then we have minus x squared plus 4x minus 2. And we have zero sums. We got negative 2 plus 2. Negative x squared, positive x squared, positive 4x, negative 4x. And this will have, I'll just rewrite it, 2xh plus h squared minus 4h. Just copy what's left over h. 2x plus h minus 4 over h. So they all have an h. Also, if we put 0, if we substitute 0, we would get 0 over 0, and that's indeterminate, so we have to rewrite it. H divides to get 1, and you substitute a 0 for h. So we have 2x plus h minus 4, 2x minus 4. 2x minus 4 is the slope. It's a formula for the slope of the tangent line at any x value. And that's asking the same question. So pause the video and try that one. Y prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. And we're going to have f will be here, or f of x plus h is here, another f over there, and f is something squared plus 3 times something minus 1. Something squared plus 3 times something minus 1. And here we're going to substitute x plus h, and over here we're going to substitute x. Expand that, 3x plus 3h. And if we don't get a lot of zero sums, then maybe there was a mistake. So we have plus 1, minus 1. We have minus 3x plus 3x, negative x squared, positive x squared. And each term has an h, so we can factor that out. 2x plus h plus 3 cancel. As h goes to 0, the limit goes to 2x plus 3, and so 2x plus 3 is the formula for the slope of the tangent line at any x value. And that is calculus. That's the derivative of the function. I'll stop there.